Hi guys. Hey, it's Monday. We have a short week this week. You guys only have school on Monday and Tuesday, and then we're out for Thanksgiving, and I won't see you until after Thanksgiving break. Monday, I'm going to meet with you guys real briefly right before you guys watch this video. We're just going to do a couple quick announcements. Hey, my grading's all caught up, so please log in PowerSchool. You'll see where you're sitting in math class currently. And I did want to tell you guys, thank you so very much for answering that question that I pushed out through Google Classroom. Hey, that was very informative for me. It's good to know that some of you guys were feeling like there was quite a few assignments, and I think you're feeling like there's a lot of assignments in all of your classes. So I'm going to try to narrow that down, and I'm going to try to keep it so that we don't have as many things rolling. I do want you to know my video is like your teacher teaching. So that is like a piece that I can't eliminate. That's a piece that has to be a part of this class. And then what's fantastic is we also have something like Nearpod and we have Edpuzzle. Nearpod and Edpuzzle would just be two platforms that I can take the subject that we're studying and I can push it out in a little bit different format so that you can hear it a little bit differently. If I'm showing it one way and you're like, wait, like I'm not totally sure I understand her, you can't go back in. I mean, you could rewatch the video, but you might still be stuck. Like it doesn't make any sense. I'm not sure that I'm getting any more clarity. The Edpuzzle and the Nearpod, those are opportunities for you guys to hear the same concept being repeated over to you again. So please don't look at like a Nearpod and an Edpuzzle as necessarily homework. Homework would be like the task cards that I just gave you guys. There were 3 different sections to that task card. I did the first section with you and then left you guys with section 2 and section 3. Section 2 and section 3 were your homework. That was your guys' practice. So every week I'm trying to embed like some kind of a practice for you guys to do that you guys can always come back and you can ask me questions over, or you can log in during our class time and you can let me know that you're struggling with a certain problem, and I will go back and I will work out through those problems with you. Now, I did like interactive notebooks, but the problem became when you guys gave me feedback was interactive notebooks that were like blanks that you guys had to go in and you had to fill out, right? It's like a notebook. I do most of the note taking for you. You follow along as I go through those notes and you put in all those answers, right? Well, that turns into almost like another to-do, another assignment, and I'm gonna try to kind of maximize our time together so that I'm not bogging you down with too much. Balance, you guys. I don't know. You have to learn the content as well. So you can expect that almost every time we have math, you will have practice work. You will have an assignment. What I have for you guys today is graphing linear equations in slope-intercept form. So I did this and I separated this out and we did it as guided notes and practice activities. So what that means is it's kind of like an interactive notebook, but it also has some practice that you guys are going to do in here as well. So the note taking I'm going to go through with you, and then when we get to the part where you guys are actually practicing, I'm going to do some of those and skip around, and others I'm going to leave for you guys to practice on your own. So the very first page that you guys are looking at looks kind of like this. It says graphing equations in slope-intercept form. So I'm going to go through this and I'm going to help you guys take your guys' notes and fill in all of those blanks. So I'm going to scoot you in so that you guys can see my board. Number 1. So number 1, we're talking about something on number 1, and it's asking you guys about the x-intercept. So I'm going to go through this and I'm going to explain a little bit more when I talk about slope and when I talk about the intercepts. The x-intercept, it says x-intercept, the x-coordinate of the point where a line crosses the, and what you're thinking of is you're thinking of where this crosses the x-axis. So we're trying to think to ourselves, that's our answer. We're trying to think to ourselves when we have a graph and you have some kind of a line that goes through there, where does that cross the x-axis at? And so when you think about that coordinate's going to have some kind of an x value, like this could be 5. It's not going to have any y value. So you're thinking of that number where it crosses the x-axis at. We're not going to write it as a coordinate generally as 5, 0. We're just going to say that the x-intercept is 5. It crosses the x-axis at 5. So you're thinking to yourself, not going up and down, where does it cross that x-axis at? So number 1, that's what the x-intercept is. Number 2, The x-intercept occurs when? It occurs when y equals 0. So that's what I was explaining. When y equals 0, when we're not going up or down at all, where does it cross that x-axis at? And it doesn't always cross on the positive side. Sometimes it crosses on the negative side, but all along that x-axis, think about it like a number line. Where does it cross that x-axis at? And that's when y equals 0. Number 3, y-intercept. The y-coordinate of the point where a line crosses the, so when we're talking about the y-intercept, what we're talking about is where it crosses the y-axis. So instead of it crossing the x-axis, we could take this exact same line that I just drew, and you're thinking to yourself, where does it cross the y-axis? So that we're looking at up and down this time. So you guys would be looking at a point here that would be 0. We didn't go left or right, and pretend that maybe we went up 2. So you're thinking to yourself, where does it cross that y-axis at? Number 4 is very much like number 2, and it says the y-intercept occurs when x equals 0. So I want you to look at this. I want you to look at that coordinate and recognize that in this coordinate, we're not moving left or right at all. We're moving up and down. So you're thinking to yourself, where does it cross the y-axis? And it can be positive. It can sometimes be negative. Where along this line does it cross? This one's where along this line does it cross. So we have x and y intercepts, and we're talking about where the graph of a line crosses the x-axis or the y-axis. Now we're going to move on, and this is what we introduced when I saw you guys on Thursday. We talked about something called slope-intercept form. So what we were thinking of is how do we write an equation of a line in something called slope-intercept form. So what I want you guys to know is that the equation is going to always look like this. You guys are going to set your solve for y. Your equation's always got to be solved for y. There's going to be nothing over on this side other than just your y. And then generally we write it in this basic form like this. And then you'll see this written over and over and over, this mx plus b. And what we mean is this m, this is going to be slope. So you guys are going to come down below and you guys are going to see right here where it says m. M's going to actually be a value. It's going to be a number, and that's going to represent our slope. Whereas the b is going to be the y-intercept. So this is where it crosses the y-axis at. Remember, we're talking about not a coordinate like 0, 5. You're just writing 5. If you wrote the 5 here, we're going to go up 5 on that y-axis, and that's going to be where it crosses the y-axis at, the y-intercept. So you should fill in slope and y-intercept. Slope and y-intercept for number 5. Y equals mx plus b. The first m part, the number around the x is always going to be your slope, and then the other number is going to be your y-intercept. Okay, so it says to find the slope and y-intercept of the graph of a linear equation, rewrite the equation in. So it doesn't matter. You can have any equation. You want to rewrite that equation in slope-intercept form. When you guys write it in slope-intercept form, and basically what I'm telling you guys to do here is I'm telling you guys to solve for y. I want you to remember about when you guys were solving equations, and we're going to try to solve this so that we got it so that it says y equals something. And when it says y equals something, you guys are in good shape. You guys can identify the slope, and you guys can identify the y-intercept. So we're going to write it. Number 6 should say rewrite the equation in slope-intercept form. Now we have 2 boxes, you guys. These 2 boxes. Here's the first one, and here's the second one. I'm going to start over here. Identify the slope and y-intercept of the graph of the linear equation. So we have y equals negative 5x minus 8. And what you guys got to identify is you guys got to identify the slope, and you guys got to identify the y-intercept. So you guys are looking at both of those. What is the slope and what is the y-intercept? So remember, this is solve for y. So you're thinking to yourself, y equals mx plus b, right? And we usually put a plus in here, but know that it can also be a negative. Remember what I said. It doesn't always have to cross on the y-axis in the positive. It can cross in the negative. It can be on the bottom as well. So if it's on the bottom, it would be a negative 8. You'd be dropping down. So the slope of this one, remember that the m part right here that goes with the x is going to be your slope. The slope should be -5. And then the b part here, we have to bring down that -8. You guys got to attach that minus part on that one. The only thing you can omit is a positive. We don't write the plus sign in front of like a 3 to identify that that's a +3. We do have to write the negative in front so that we know that it's a -3. So my slope for this one would be -5. My y-intercept would be -8. All right, now we're going to jump over to the next one. And this next one I really need you guys to pay attention to because this next one looks a little bit different. It says y plus 3 equals 1/2 x, right? So I want you to notice right away when we compare this to y equals mx plus b, notice that this is all solved for y. This one says y equals. This one says y plus 3 equals. Not solve for y. So I can't just jump in here and start finding slope and intercept. I actually have to get this y by itself. This says y equals. This says y plus 3 equals. To get the y by itself, I have to undo the plus 3. Remember when we solve equations, to undo and add 3, I'm going to subtract 3. Right? But remember that in equations, it's like a balance. If you guys are looking at it, and I'm trying to keep my hands level. If you guys are looking at it like this and we go and we add 3 here, to keep it equal, I have to add 3 on the other side. I can't just add on one side because then it's going to keep my balance off. So if I'm going to subtract 3 on this side, I also have to come over here and I have to subtract 3 on this side. So now this add 3 and the subtract 3 are going to undo each other. So I don't no longer have y plus 3 because I took y plus 3 and I minus 3. So I just get the y. And remember on this side, remember when you guys talked about like terms, you can always combine like terms. But this is it. This is 1/2 x. This is not 3 x's. So I can't combine those. It's not like x and x's that I can put together like apples and apples. This is 1/2 of an apple. This is just a -3. There's no apples there, so I can't put them together. So I have to rewrite this as 1/2 x, and I got to go and just do the -3. Now, when we go back and we think y equals mx plus b, remember that this is slope, the m part, and that this part here is the y-intercept. So remember that the back end is y-intercept, the m is the slope. So now this is solved for y. Front part looks identical, y equals. I'm going to come over here and I'm looking in front of the x. That's going to be my slope. So my slope should be 1/2 equals the slope. And then this piece at the very end is going to be my y-intercept. And I have to hold the minus. Because remember that it can cross in the positive side of the y-axis or the negative side. So this is going to be -3 is going to be my y-intercept. So you guys should answer is 1/2 is your slope. -3 is going to be your y-intercept. So what you guys are doing is you guys are actually taking these equations and we're trying to solve them for y. When they're solved for y, you should clearly see a slope and you should clearly see a y-intercept. Now it says you can graph a line. Okay, I'm going to move on to number 7. You can graph a linear equation in slope-intercept form. So now we're going to go through it. Step 1, 2, 3, 4. So here it is. We are looking at, now this is what you guys are really practicing today, is you guys are really getting this graphing piece down. So it's asking you guys to graph y equals 1/2 x plus 1. Okay, so what you guys are going to do, it says step 1, right? So here we are, step 1. Step 1 says for you guys to identify the slope and y-intercept. So the first thing you want to figure out is what is the slope, what is the y-intercept? So remember that this is that if it's not solved for y, you have to solve for y. But since this one's solved for y, I get to look at the number in front of the x, and I get to look at that number after the x. The number right directly with the multiplication with the x, this is going to be the slope. The number at the very end is going to be the y-intercept. So I know my slope of this line is 1/2, and I know my y-intercept is 1. So I have identified those. Step 2. So I'm going to jump down here, and step 2 says that I need to plot. So I'm going to actually graph the y-intercept. So I'm going to come over here on your guys' graph, it says that my y-intercept is 1. So what that means is I should go up 1 because it's a positive 1. I'm going to put a dot. That's where it crosses. And remember, this is your y-axis. So where it crosses on the y-axis is 1. All right. Now it says step 3. Step 3 says for us to use slope. So we're going to use slope to find the next point. Now this might be the trickiest part. I'm going to tell you guys right here. So watch what I'm doing, and this should help you a lot today. Slope of this line is 1/2. Remember that this is change in y over change in x, right? So you're thinking to yourself, what's happening on the y-axis and what's happening on the x-axis? What's happening on the y-axis is it says that it's a positive 1. So it's telling me I should go up 1. So I'm going to come over here on my graph, and I'm going to go up 1. But I'm not done because there's also a change in x. The change in x is a positive 2. So that tells me that I have to go in the positive direction on the x-axis too. So I'm going to head over here 1, 2. I went up 1/2, and I'm going to find this the next dot. You could always do another one if you need to. A third one, up 1/2 more, and do a third one. Remember that slope's always going to be up 1/2, up 1/2, up 1/2, and they're all going to connect together, and they're going to make a straight line. Now your guys's will make a much straighter line than mine will because you have grid paper. I'm gonna try to work on my interactive board that I have here at Riverside and try to get some of those that grid paper up for you guys so that you can see me do some of this a little clearer. So then then the last part is just what I did, connect the 2 dots. So step 4 was just like take those 2 dots and draw a line through them, and you got your slope-intercept graphed. So here's what we're going to do. We're going to move on. This is practice graphing equations in slope-intercept form. So you guys got 6 problems on there. I'm going to do a couple of them, and then we're going to jump over to some vocabulary, and I'm going to help you guys with some of that too. So we're now at the practice part. So the practice part, this is kind of like where you guys would be thinking like, okay, this Woodard just taught me. I now have to practice and I have to do some of these problems on my own. So I'm going to look at number 1, and I will leave you guys to do number 2. And number 2 actually is going to be a little bit harder. Number 2, you guys don't have y solved for itself. I might do number 2 because I think you need to see me do that again. We have y equals negative 1/3 x plus 2. And it's asking you guys, what is the slope? What is the y-intercept? So you're just doing a lot of identifying for number 1 and number 2. It's just looking at this y equals mx plus b and identifying which one's which. So remember, you're looking at the number right in front of the x and the number after the x. My slope is the first one, which is negative 1/3. My y-intercept is going to be 2. It's going to be that last one. And this time I don't have to write the plus 2 because it's understood that this is just a positive 2. So there's number 1. I'm going to show you guys number 2, though, because I thought I could leave you guys with that one. But this one is that one where I just told you guys, when you look at this, it says 4 plus y equals negative x. Now, this is that one that I was telling you guys about. You're trying to get this into y equals mx plus b form. What I want you guys to notice is that we're solved for y in this one. If you look at this one, this says 4 plus y. It's not solved for y. I'm trying to get this y so that it's all by itself. I have this 4 that's here that's kind of messing me up. That 4 is like a positive 4. It's like a plus 4 that's sitting there. I'm going to subtract 4 to get rid of that. Now, if I do that to one side, I have to do that to the other side to keep them equal. I can't just subtract 4 here and then leave this. I have to balance them out. So I'm going to subtract 4 here, and I'm still equal. This is just saying like this is just plus y. So this is like a positive y. So I'm going to come down here and just write that y. This 4 minus 4 is just going to wipe itself out, which is what I need. I got to get that y by itself. So it said y equals. Now, remember the x is written first. This isn't like a minus x minus 4x. So remember when you guys were doing like terms, when you guys were combining like terms in last year, when you guys were combining like terms, you would go like 3x plus 7x is 10x. You would put those x's together. But you couldn't take 3 plus 7x. They're not like terms. This is over here saying I have 7 apples. This is saying I don't have any apples. I can't put them together. If I have 3 apples and 7 apples, I can put them together and get 10 apples. This is negative, so this is a minus x, and then I minus 4 from that. And the reason I put the x first is because that's how this is written in slope-intercept form. The x is first, and then the number, just that plain number comes. Now you guys can identify what is the slope and what is the y-intercept. So I'm going to look at this, I'm going to go slope, y-intercept. My slope is this number that's in front of the x, and then my y-intercept is going to be this number at the very end. Remember, the only number we don't have to write, if this is a minus x, is a 1. So my slope actually is negative 1. So what I'm talking about is I'm talking about like the change in y over change in x. We're talking about like a minus 1 and then over 1. So you're thinking as a fraction 1 over 1, right? And then the y-intercept is negative 4. You have to remember these minus signs. Those minus signs are super important. That's going to tell me if it's positive or negative. So my slope was negative 1. My y-intercept was negative 4. That's number 2. All right, guys, now I'm going to do a graph, and I'm going to see how you guys can do maybe on the last 3 graphs. So I'm going to do number 3, and number 3 is a graph again. So we're looking at y equals negative x plus 1. All righty, guys, here we go. I got my graph paper right here. First thing I want to figure out is what is the slope and what is the y-intercept. So I'm looking at the number in front of the x and then the number right after the x. That m part, remember what I just said, is negative 1. And then my y-intercept is a 1. It's a plus 1. Now what I'm going to do from here is you guys are going to come over on your guys' graph. The y-intercept is just telling us where it crosses the y-axis. So here's my y-axis. It's the one that goes up and down. Since this is a positive 1, I'm going to go up 1 and I'm going to put a dot. That's the easy one. The hard part is how do we use this slope minus 1 to graph the next point. So I want you guys to think about this. We can write a negative 1 as negative 1 over 1. You also can write it as 1 over negative 1. It doesn't matter if you, just remember that this is like a divide. And when you guys divide integers, if they're the same, if it's a positive and a positive or a negative and a negative, the answer is always going to be a positive. If they're different, if I have a positive and a negative or a negative and a positive, my answer is going to be negative. And my overall slope here is going to be a negative 1. And remember that the graph should look like something like that, like it's a negative. As I read it from left to right, it's going to go down. So as I'm looking at my points, I should be going down some way. So you can either choose to go down 1 over to the right 1, or you can go up 1 to the left 1. I'm going to show you both of those so that you can see how it forms a line, all right? So I'm going to choose to go, this is change in y, so we're talking about change in y, over change in x. So I'm starting with my y-axis, and I'm going to go down 1, and then it's telling me this is a positive, so to go right 1. So I'm going down 1, right 1. That's going to be my next point. All right, I'm going to show you guys that if you wanted to flip that and you want to attach the negative here, that works as well. This tells me change in y is positive 1, so I can go up 1. And then this tells me to go to the left 1. So I'm going to go over here and I'm going to go left 1. If I go up 1 and left 1, look at this dot. They all form a line. So with slope, when you guys are talking about just a plain number, if it's negative, you can choose to go down and then to the right, or you guys can choose to go up and to the left. Down and to the right is a negative, and up and to the left is going to be a negative. So it's showing you guys, and look, it worked out to be a graph that looks correct. It's an overall negative slope. So there is number 3. That's what your guys' graph should have looked like on number 3. Number 4, I'll do number 4 and then leave you guys. No, I'll do number 4 and then I'm going to do some, I got a couple more left to do. Look at my time. Oh, we're pushing on to like 30 minutes. Let me think here. I want you guys to try to do number 4, 5, 6. Let me know if you guys have questions. Let me explain this page. This page is you guys doing some notes over vocabulary. So what I have here is I have this word slope-intercept form in the middle. And what you guys are doing is I want you guys to come over here and give me an algebraic example. then I want you guys to define it to me. What does it mean to you? And I want some examples over here. And then I want you guys to do non-examples. So I'm going to do this one really quick. The algebraic example of this one, think to yourself that you're doing just the overall formula. What does that actually look like? This is what I taught you guys where you have slope and you have y-intercept and y equals mx plus b. The definition of this is just a way to write an equation when you know slope and y-intercept. This is just, and it helps us too with graphing. So it's like a really, really helpful tool for us to be able to graph. And then some examples over here would be y equals 3x plus 2. Y equals negative 1/4 x minus 8. You guys can do a bunch of these where you got numbers in front of the x and numbers at the very end. Non-examples would be 2x plus 3y equals 7. That's a non-example. That is not solved for y. It does not look like y equals mx plus b. I want you guys to try that with y-intercept. And then I'm going to wrap up here, guys, on this last one. This last one's asking you guys to compute some slopes when you just know the 2 points. You guys actually, it says, what is the slope of the line that passes through these 2 points? And you're not doing any graphing on these ones. It's just asking you for the slope. I do want to do this because this is just a nice way for you guys to be able to do this without graphing. If graphing is like slowing you down and trying to find grids and counting across is really tricky. What you guys are always thinking of with slope is you guys are always thinking change in y over change in x. So you're thinking to yourself, how is it changing on my y-axis? Am I going up or am I going down? How's it changing on my x-axis? Am I going left or am I going right? Change it when you guys are talking about the change in y over change in x. Change is not like taking where you're starting on the y-axis and then where you go to and adding those, because if you start here and you go to here and you add those, you're going to end up way at the top. The change is going to be what's the difference between these two. So if you start at 3 and we go to 10, the answer is not 13. The answer is the difference between 3 and 10, which is 7. 7 hops to go from 3 to 10. So we're always thinking to ourselves that we're going to do some subtraction, and this is why we went back and we subtracted integers. This is why we reviewed this, because you guys are thinking that you're going to do some subtracting. What I want you guys to think of is I want you guys to look at these coordinates, and I want you to think about if I was to give you guys these as x1, y1, and this is x2, and this is y2. If I was to give you guys these, I want you to think about subtracting these. I want you to think about subtracting y1 minus y2 over x1 minus x2. Now, what you have to keep in mind is when you guys are doing the subtraction, it doesn't matter if you label this is the first point or this is the first point. I could make this one be x1 and y1. That's why I kind of almost hate giving you this formula. The main thing for you guys to remember is if you start your subtraction over here, let's say I start my subtraction over here for the y coordinate, I have to start my subtraction with the 3 for the x coordinate. So what you guys are computing here is you guys are going to start over here. We're going to look at the difference. We're going to look at if we start at 9 on this, if we're up here 1, 2, 3, 4, 5, 6, 7, 8, 9, if we're way up here to get to 5, what's the difference? So you're taking 9 minus 5. You're starting at 9 and we're hopping down. 9 minus 5 is going to give me a 4. Now, if I start right here with 9, I am forced to start right here with 3. I cannot hop over here and do 2. I have to start with this coordinate as well. I'm going to take 3 minus 2. 3 minus 2, I'm going to take the y's minus each other, 9 minus 5, and then I'm going to take the x's minus each other, 3 minus 2. 3 minus 2 equals a 1. Write it as an overall fraction, 4 over 1, or you can just write this slope as 4. And in y equals mx plus b form, the m would be written as a 4, not as a 4 over 1. It would be understood that it was a 4 over 1. So the difference to go from the 3 to 2 is hopping 1, and then from 9 to 5 is hopping 4. I hope that makes sense to you guys. Let me try one more, and then I'm going to wrap up for today and give you guys some time to practice and know that there's like Nearpods. There's more examples for you guys to be able to look at. So I have 0, 0, and then I have 4, 6. All right. So what you guys are going to do is, and I'm going to maybe try this in a little bit different order. My brain always goes, okay, y coordinate, y coordinate. I like 6 minus 0, but let's say you were somebody and you did 0 minus 6. If you did 0 minus 6, you're going to get a negative 6. If I choose 0 first here, I have to choose 0 first here. So I'm going to go 0 minus 4 down below. 0 minus 4 is a negative 4. So this is change in y, 0 minus 6, over change in x, 0 minus 4. So I get a negative over a negative. So I got negative 6 over negative 4. To simplify this, a negative over a negative is going to equal a positive slope. And then I can reduce this to be 3 over 2. You do not have to write the plus sign. You could just write it as 3 over 2. And I'm going to show you guys, let's say that I inverted that. And let's say like your classmate went the other way. Let's say that we had 0, 0, and then let's say we flip this 4, 6, and let's say instead of going 0 minus 6, let's say we do 6 minus 0. So 6 minus 0 is going to be 6, and then let's do the same order. I got to choose, if I choose the 6 first here, I got to choose 4 first next. So it's going to be 6 over 4. So 6 over 4 written as a fraction looks like that, and reduced, it's 3/2. So you guys, the purpose in doing them in the exact same order, so if you know you get a positive slope or a negative slope. Super important. If you invert them, you're going to invert them. Your numbers will be the same, but you're going to have the wrong sign on your slope. I'm going to give you guys time to do today the last 2 problems. And then I want you guys to practice some of these graphings that I showed. And then there's a few more graphings. There's exit slips. You guys got a few more on the exit slips. Now, I'm going to be available. We're pushing 31 minutes, and I know that's a long time for you guys to sit. So I'm going to make myself available and go guardian today to help you guys. And I'm not going to push a whole lot more towards you. I am going to open up I believe I opened up a Nearpod. Let me just double check in Google Classroom really fast. I did do a Nearpod, and that's all I'm going to have you guys do. I'm going to, between this thing right here, so what you guys are trying to get done today is I want you guys to finish this. So I want you guys, so here's your to-do today. Your to-do today is going to be, I want you guys to go in and I want you guys, I'm going to get a better marker for you guys. I want you guys to finish this. So I want you guys to finish this guided notes and practice. And I'll be here if I didn't show enough here and you need me to go through and show that other example, or you need another walkthrough, please let me know. I'll grab you and we can work together some more. And then after that, I want you guys to take a look at that Nearpod. That Nearpod should help seal this concept a little bit more. One more person explaining it to you guys. And then for this week only, we're gonna look at, you know what, you guys, I'm actually feeling like we're heading out for Thanksgiving. And I'm feeling like, you know what, today can kind of be a day where we just slow down and we just get to have some community with each other. And you guys can talk with me and we can just make sure we're all feeling okay. I want to just hear from you. So what I'm gonna say, there's no ST math. This is gonna be it for the week. And then what I want you guys to do for me is just to have a very, very happy Thanksgiving. I hope you guys eat lots of great food. I hope you guys maybe get to relax and enjoy some time with your family. I do want each and every one of you guys to know how grateful and how thankful I am for you. You guys make my day. Your guys' joyful attitude and hard work and hard effort and just the way you guys approach this class. I am very proud of you. And I'm super, super, super thankful that I get to be with you guys. You bless me. So thank you guys very much. Happy Thanksgiving. Let's work on this and let's get that Nearpod finished. And then if you guys are feeling good about all of that, let me know. I could probably shoot out. I do have an Ed puzzle. If you want to try to attempt an Ed puzzle for some extra credit, let me know. I'll give it to you. Thanks, guys. Happy Thanksgiving. Bye.